North reference conversion problems. This video presents 5 north reference conversion problems for you to solve. Each problem will state the conversion to be performed and provide a declination diagram to use. If you want to solve the problem on your own, pause the video, do the conversion, and then continue playing the video to see the solution. The problems will explore different combinations of grid and magnetic north on either side of true north. They will also get a bit trickier as they progress. Once you feel that you have the hang of this, I'd suggest you dig out a map of your local area and try a few north reference conversions using your declination values. Problem 1. Convert a bearing of 285 degrees grid to a magnetic bearing. Remember, when you're working with the declination diagram, bearings increase in a clockwise direction. Magnetic north is 16 degrees east of true north. Grid north is 1.5 degrees east of true north. The angle between grid north and magnetic north is the 16 degrees from magnetic to true, less the 1.5 degrees from true to grid, or 14.5 degrees. Let's round that up to 15 degrees. Now draw the 285 degree grid bearing onto the diagram. Start at grid north and go in a clockwise direction. The answer we are seeking is the angle from magnetic north to the target. In this case, the magnetic bearing we are seeking is smaller than the grid bearing we were given. So, we subtract 15 degrees from the 285 degrees grid value to get the answer of 270 degrees magnetic. Now let's make our shortcut rules for this situation. To convert grid north to magnetic north, subtract 15 degrees from the grid bearing. To convert magnetic north to grid north, add 15 degrees to the magnetic bearing. Problem 2. Convert a bearing of 67 degrees magnetic to a true bearing. Magnetic north is 12 degrees west of true north. Grid north is 1 degree 42 minutes west of true north. The angle between true north and magnetic north is 12 degrees. Draw the 67 degree magnetic bearing onto the diagram. The answer we are seeking is the angle from true north to the target. In this case, the true bearing we are seeking is smaller than the magnetic bearing we were given, so we subtracted the 12 degree difference from the 67 degree magnetic value to get the answer of 55 degrees true. To convert magnetic north to true north, subtract 12 degrees from the magnetic bearing. To convert true north to magnetic north, add 12 degrees to the true bearing. Problem 3. Convert a bearing of 108 degrees grid to a magnetic bearing. Magnetic north is 9 degrees east of true north. Grid north is 25 minutes east of true north. The angle between grid north and magnetic north is the 9 degrees from magnetic to true, less the 25 minutes from true to grid. That would be 8 degrees 35 minutes, which will round up to 9 degrees. Draw the 108 degree grid bearing onto the diagram. The answer we're seeking is the angle from magnetic north to the target. In this case, the magnetic bearing we are seeking is smaller than the grid bearing we were given, so we subtract 9 degrees from the 108 degrees grid value to get the answer of 99 degrees magnetic. To convert grid north to magnetic north, subtract 9 degrees from the grid bearing. To convert magnetic north to grid north, add 9 degrees. Problem 4. Convert a bearing of 11 degrees grid to a magnetic bearing. Magnetic north is 18 degrees east of true north. Grid north is 1 degree 15 minutes east of true north. The angle between grid north and magnetic north is the 18 degrees from magnetic to true, less the 1 degree 15 minutes from true to grid. That would be 16 degrees 45 minutes, which will round up to 17 degrees. Draw the 11-degree grid bearing onto the diagram. The answer we are seeking is the angle from magnetic north to the target. Remember, the angle needs to go clockwise from magnetic north to the target bearing. In this case, the magnetic bearing we are seeking is smaller than the grid bearing we were given, so we subtract 17 degrees from the 11-degree grid value. This gives us a result of minus 6 degrees. Bearings need to be given in terms of a 0 to 360 degree circle, so add 360 degrees to the minus 6 degrees to get the answer of 354 degrees magnetic. To convert grid north to magnetic north, subtract 17 degrees from the grid bearing. To convert magnetic north to grid north, add 17 degrees to the magnetic bearing. Problem 5. Convert a bearing of 350 degrees magnetic to a grid bearing. Magnetic north is 14 degrees east of true north. Grid north is 1 degree 45 minutes west of true north. The angle between grid north and magnetic north is the 14 degrees from magnetic to true, plus the 1 degree 45 minutes from true to grid. That would be 15 degrees 45 minutes, which will round up to 16 degrees. Draw the 350-degree magnetic bearing onto the diagram. The answer we are seeking is the angle from grid north to the target. In this case, the grid bearing we are seeking is larger than the magnetic bearing we were given, so we add 16 degrees to the 350-degree grid value. This gives us a result of 366 degrees. Again, bearings need to be given in terms of a 0 to 360 degree circle, so subtract 360 from the 366 degrees to get the answer of 6 degrees magnetic. To convert magnetic north to grid north, add 16 degrees to the magnetic bearing. To convert grid north to magnetic north, subtract 16 degrees from the grid bearing. I hope you found this tutorial useful. The next video in this series will show you how to work with plotting and reading bearings on your map. You can find additional videos, the written script for this video, and downloadable exercises in the tutorials section of the MapTools.com website. MapTools.com is a leading manufacturer of coordinate plotting tools and a great source of information for land navigation instructors and their students. Thanks for watching.